You've just worked through a batch of tricky problems with Sarah, and maybe the results of the programs were not always what you expected. That's why it's such a good idea to test your programs to see that they produce the right result. Testing is incredibly important in software engineering, and when testing isn't done right, the results can be quite dramatic. Over here, you see the liftoff of a rocket, an Ariane rocket of the European Space Agency, that unfortunately, a few seconds afterwards, explodes in midair. Now what happened here is that the rocket had a device to maintain its position, and it actually had two backups. And because of that, the rocket engineers didn't think they had to test it. But both backups failed for the exact same reason, actually, and testing really would have been beneficial in this case. So let's learn more about how you can test your own programs. Okay, here we are in BlueJ, and I'm going to write a program that tests the translate method of rectangles. Let's have a look. Here, we construct a rectangle. We call the translate method. We print out what happens to the x-coordinate, and we also print out what happens to the width of the rectangle. And now for the important part. The important part is that before compiling the program, we also think, what should it do? And it is really, really important that you think about that right when you write your test program. Here is a super easy way of doing that. You simply add a print statement that prints what you expect that this program should do. What do we expect? Let's see. The x-coordinate of the rectangle is at 5, the y-coordinate is at 10, and now we translate it by 25 pixels to the right and 15 pixels down. So we have a 5 translated by 25 pixels, so we expect that the x-coordinate is now 30 pixels, and that's what I'm putting here. What about the width? The width is 60, and moving the rectangle shouldn't change it, so we'll expect it to be 60 again. So this is a good example of a tester program. We do something, we print the results, and we print the expected result. Let's quickly run the program. We have the actual x position of 30 and the expected position of 30. And similarly, we have the actual width of 60 and the expected width of 60. So the actual and the expected match up. That's great. So the simple lesson is always print the actual and the expected results. Sarah has an activity where you can write your own test program and practice this.